In this problem, we were trying to find out who shot Mr. Godwin. So we were given an apparatus, and with this apparatus, we were told we have the shooter's gun. We have a gun, and the gun that we have is the businessman's gun. So we want to figure out what is the speed of the bullet from this businessman's gun. So here's the apparatus we were given, and we were able to measure some, or take some measurements. Okay, so you may have found some different numbers, but and it depends on the apparatus that you're using. But here's one example. We could find the angle to be about 22 degrees, the mass of the block to be 80 grams, the mass of the bullet to be 8 grams, and the length of a string. So the length of the string would be that length or this length. It doesn't matter which way you measure it. It could be 24 centimeters. So here's our scenario. We've got a bullet inside of a block, and then it swings up to some height, and we know this angle right here, 22 degrees. So maybe we can use the conservation of energy to find out something about the kinetic energy at this location. If we know at the highest location its kinetic energy is 0, so we don't need to worry about that, but it has gravitational potential energy. So at the beginning it has kinetic energy, and at the end it only has gravitational potential energy. So if you see, the mass is cancelled. If I get that V by itself, I get 2gh, multiply both sides by 2, and then I take the square root of that. Now the hard part is figuring out what is the height. What is the height that this block rises to? That's what we need to know to figure out what the speed is. So here it's shown on the diagram here. This is what the height is. It's how high it rises. So hopefully you would agree that height from the bottom of the block to the bottom of the block is the same as this height, the top of the block to the top of the block. So this is what we're trying to find. So we have a right angle triangle that we might be able to exploit. Here it is. So I know something about this right angle. I know the angle, and then I also actually know one of the hypotenuse. So that's the length of this string. 24 centimeters is this entire length. It's the entire length of the string. Maybe I can use that to figure out what this value is, what this length is, and I'll call it y. Maybe I can find out what y is, and then use y to find h. So I'll show you how to do that. So the first part is, let's try to figure out what this length y is. So I'm going to use SOHCAHTOA. I'm going to say cos of 22 degrees is equal to adjacent, which is y, all over my hypotenuse, which is 24 centimeters. Isolate for y, put that in my calculator, and I find it's 22.3 centimeters. Okay, so now I know y, and I want to find h. So let me use some colors here, it might help you. This length right here, we said is 24 centimeters. This length, y, we just measured to be, or we just found using right angles to be 22.3 centimeters. So if I want to know what h is, well, I can say, well, h plus 22.3 must give me 24 centimeters. True? So 24 centimeters is equal to 22.3 centimeters plus h. So let me get h by itself. 24 minus 22.3, and that gives me 1.7 centimeters. So I'll convert that to meters now, because I know g is negative 9.8, or it's 9.8 meters per second squared. Oops, I made a mistake there. 1, 2, yeah, divided by 100. So that's how many meters it is. So let me plug it back into this formula I created. 2 times 9.8 times 0.017. Put that in my calculator, and I get 0.58 meters per second. So that's the speed of the block and the bullet moving together. But we're trying to find out what the speed of the bullet is by itself. So let's picture what's happening here. I have a bullet and I have a block, and then there's a collision, and now my bullet and my block are moving together. And we just found what this speed is. Right? We just found this speed is 0.58 meters per second. What we're really looking for is how fast was the bullet moving. This is just an apparatus to help us figure out this question. How fast is the bullet moving? Okay, so I see a collision here, so I'm thinking conservation of momentum. This is before my collision, and this is after my collision. So let me call the mass of the bullet M1 and the mass of the block M2. So M1, I would convert this into kilograms. So to go 8 grams times how many grams? 1,000 grams in 1 kilogram. The word kilo means 1,000. So it's divide by 1,000. And what you're going to see is that gives me 0.008 kilograms for the mass of the bullet. We don't know what the speed of the bullet is, but this is at rest to begin with. So my speed is 0. I don't have to worry about that. Now after they collide, and now they're moving together with the speed that we found. So this is the mass of the bullet, and it has that speed. And the mass of the block, also divide by 1,000. You'll find this for the kilograms, the mass. And it has the same speed. So this is the mass of the block, the mass of the bullet. So if we isolate, get V1 by itself, I would add these two numbers and then divide by this number. So here we find that the bullet is moving 6.4 meters per second. So again, you might have different numbers, but we're just going to take this one as an example. And let's look at the police report and see if we can rule out a suspect. So here it is. It says, during the investigation, it was found the bullet which hit the victim in the shoulder is traveling 5.7 plus or minus 1.8 meters per second. So what does that mean? Well, that means the fastest it could have been going, so 5.7 plus or minus 1.8. Let me write that down. 5.7 plus or minus 1.8 meters per second. So the fastest it could have been going is 5.7 plus 1.8, and the slowest it could have been going is 5.7 minus 1.8. So 5.7 plus 1.8, that would be 7.5 meters per second, and the slowest it could have been going is 3.9 meters per second. So this bullet falls within that range. So we know that this was from the businessman. So his bullet, I mean, he could be one of the shooters. It falls within this range. So let's see if we can rule out a different suspect. So let's go here. The grandma dropped her gun, leaving her model of the gunfires was 7.2. So again, that is within this range as well. So we can't rule out the grandma or the businessman. So let's see if we can rule out the tattoo artist. The tattoo artist and the businessman had the same model of gun. The tattooed artist was seen to have a silencer on it which decreases the speed of the bullet by 50%. So 50% of this number, well, that's just that number times 1/2, or 3.2 meters per second. 3.2 meters per second is not within this range. It's too slow. So right off the bat, we can say that it couldn't have been the tattoo artist which fired the gun that shot Mr. Godwin. So now we're down to grandma and businessman, again with the numbers that I've been using. So at this point, we've got to figure out which one of them did it and which one it didn't. My recommendation for you was to look at the bullet in the wall. So the bullet that's in the wall can give us some information. If we find out that the bullet in the wall was from the businessman, well then it must have been the grandma that shot Mr. Godwin. Or vice versa. If we find the bullet in the wall is from the grandma, then it must have been the businessman that shot Mr. Godwin. So the bullet in the wall, we know that it was roughly, you can measure this on the ground, but it's roughly 3.5 meters from the wall. And the height that it was above the ground was roughly 22 centimeters, which is 0.22 meters above. So let's see if we can use some of the information that we know to figure out whose bullet it is that it's actually in the wall. So let's see maybe the things that we know. Let's write them down and see what we can find out. So looking at this problem, this is as soon as the bullet leaves the gun, it becomes a projectile motion problem. The only force acting on it is the force of gravity. So we can apply the kinematic equations. So the grandma, it says in the document that her gun is fired at 7.2 meters per second. Now I'm going to assume that the guns were fired horizontally, which means the initial velocity is only in the x direction. There's no initial velocity in the y direction. Acceleration in the x direction is 0, and the y direction is 9.8. In the x direction, both of them would have a change in x of 3.5, assuming they fired from the same position. The change in y, we're not sure. We're not sure what those values are. But here's the plan. What I'm going to try to do is find the delta y for both the businessman and the grandma. And I'm going to use this equation. I'm going to look in the x direction first and find time. So I'm going to use this equation. This is one of the kinematic equations. To find my time. And then use my time to find what my change in y is. So I've plugged in my values, delta x, vix. The acceleration is 0 in the x direction for the grandma. So I can cancel this term. I divide both sides by 7.2, and I find that the time that it takes is about 0.5 seconds. So now I'm going to use the same equation, but in the y direction, to find the change in y. So I plug in my values. Remember, the initial velocity in the y direction is 0. So this term cancels. What I'm left with is delta y equals negative 1.18. And this is again for the grandma. I'm going to do the exact same process for the businessman. So I'll do that over here. So what I find for the businessman is that the bullet is going to fall 1.48 meters. So how can I help us solve my mystery? Well, so we know the grandma's bullet would fall 1.18 meters and the businessman's 1.48. So if we take a look at their mug shots, we can see, well, assuming they held out the gun from about shoulder height, the grandma's shoulder height is 4 feet 6 inches, so between 4 and 5 feet. You convert that to meters, that's 1.37 meters. Similarly for the businessman, 4 feet 10 inches, about 1.47. So I'm running out of time here. But what you can see is that the businessman, his bullet would be right at the ground. If it falls the exact same height as he is, his bullet mark should be right at this location. So based